used are first one, hydrogenation in presence of ruthenium carbon. Hydrogenation in presence of copper, barium, chromium. Similarly, hydrogenation in presence of Cu2Cr2O5 or the same Cu2Cr2O5, it is cupric oxide and chromium oxide, Cr2O3, or simply we can say copper chromate. Right? Now, see, another one is another reducing agent, lithium aluminum hydride. Lithium aluminum hydride, it reduces carboxylic acids into alcohols, right? Whereas sodium borohydride is not possible. Sodium borohydride, it cannot reduce carboxylic acids into alcohols. See, lithium aluminum hydride, it may give LiAlH4 or AlH4 minus. AlH4 minus. So these reagents are sufficient. There are some other reagents, but all those reagents are not required, right? So this is about preparation of alcohols from different compounds. Now let us discuss properties. First, let us discuss physical properties. Let us take different alcohols like methanol, ethanol, N-propanol, N-propyl alcohol, N-butyl alcohol, or N-butanol. First, let us take boiling point. See, boiling point, it is directly proportional to intermolecular attractions. If intermolecular attractions are more, boiling point will be more. Now, intermolecular depends on surface area of the molecule. Surface area depends on chain length, carbon chain length. So the alcohol with more number of carbon atoms in a straight chain will have more surface area, that will have more intermolecular attractions. Hence, its boiling point would be more. So on moving from methanol to butanol, number of carbons are increasing and there are no branches. So surface area increases. Van der Waals attractions or intermolecular attractions increases. Hence boiling point increases. So boiling point of N-butyl alcohol is greater than that of N-propyl alcohol is greater than that of ethyl alcohol is greater than that of methyl alcohol. Now, let us take melting points. See, melting points also directly proportional to van der Waal attractions or intermolecular attractions. Right? See, when a substance is solid, to convert it into liquid, solid substance converts into liquid on heating. If attractions are more, it requires more temperature. If attractions are less, it requires less temperature. So just now we have discussed that intermolecular attractions or van der Waal attractions, they depend on surface area. Surface area depend on number of carbons in the straight chain. So among these four alcohols, N-butyl alcohol is having more number of carbons in straight chain, hence surface area would be more, intermolecular attractions would be more, hence its melting point would be more. So melting point of N-butyl alcohol is greater than that of N-propyl alcohol is greater than that of ethyl alcohol is greater than that of methyl alcohol. Now, next property is solubility. Solubility in water or any solvent. In most of the cases, we consider water. See, for solubility, we have to consider two things. One is hydrogen bond formation. Second one is repulsions between water molecules and carbon chain. First point is hydrogen bond. Hydrogen bond. Second one is repulsions. Repulsions between carbon chain and water molecules. Right? See, see carbon chain, it is hydrophobic. Carbon chain is hydrophobic. Hydro means water, phobic means hate. So carbon chains, they do not interact with water molecules. So they are hydrophobic. So as number of carbon chains increases, hydrophobic nature increases. If hydrophobic nature increases, solubility decreases. So with respect to number of carbons, in methanol 1 carbon, ethanol 2 carbons, propanol 3 carbons, butanol 4 carbons. So butanol, there are more number of carbons. So butyl chain will have more hydrophobic nature. So butyl alcohol solubility is less in water than that of propyl alcohol is less than that of ethyl alcohol is less than that of methyl alcohol. Now, what about hydrogen bond? See, hydrogen bond is common in all alcohols because OH group, there is only one OH. So with respect to number of hydrogen bonds, we cannot differentiate the solubility. But with respect to carbon chains, we can differentiate the solubility based on hydrophobic. As the number of carbons increases, hydrophobic nature increases, solubility decreases. So based on this, solubility of methanol is greater than that of ethanol, is greater than that of propanol, is greater than that of butanol. Right? Now, let us take branching. All of are clear up to here? Let us take branching. Say, this is N-pentanol. N-pentanol. Our common name is N-amyl alcohol. N-amyl alcohol. Now let us take isopropanol. Right? Here two branches. Here no branches. Only single chain, straight chain. Here one branch is there. Suppose if you consider two carbons in one chain, one branch. Now let us take two branches. If, right, two branches. Or with respect to the carbon bonded to the OH group, here one, here two branches, here three branches. So on moving from first compound to third compound, number of branches are increasing. If number of branches increases, how boiling point varies? See, boiling point directly proportional to surface area. So in N compounds, normal compounds without branches, surface area would be more, intermolecular attractions would be more, so boiling point would be more. So as the number of branches increases, surface area decreases. If surface area decreases, intermolecular attractions decreases, boiling point decreases. So boiling point of N-pentyl alcohol is greater than that of isopropyl alcohol is greater than that of tertiary butyl alcohol. Now what about melting point? See, in case of melting point, it increases. Melting point increases because, see, here as the number of branches increases, compactness increases. Compactness increases. So as compactness increases, molecules are tightly packed or closely packed. When they are tightly packed or closely packed, there will be more intermolecular attractions. So melting point increases. Right? Now, solubility in water. See, here five carbons are in the form of straight chain. Carbon chain is a hydrophobic, right? So here carbon chains are more, here three carbons, here four carbons. But on as the number of branches increases, as the number of branches increases, the compactness increases, or the hydrophobic nature decreases. Hydrophobic nature decreases. If hydrophobic nature decreases, then solubility increases. So solubility of tertiary butyl alcohol is greater than that of isopropyl alcohol is greater than that of N-pentyl alcohol. Right? So compactness of hydrophobic part. Clear? Now let us discuss acidic nature or acidic character of alcohols. See, let us take CH3OH, methyl alcohol, C2H5OH, ethyl alcohol. Next, isopropyl alcohol. Next, tertiary butyl alcohol. First, let us see basic concept of acidic nature. See, the acid which can donate proton easily. The acid which can donate proton easily is good acid or soft acid. In alcohols, there is hydrogen. Hydrogen bonded to more electronegative oxygen. So this bond is more polar. Hydrogen gets partial positive charge, oxygen gets partial negative charge. Now, if oxygen is releasing proton, then oxygen converts into the O minus anion. O minus anion after losing the proton, right? So by releasing the proton, alcohols, they act as acids. Their nature is acidic nature. This is one. Next, if this O minus ion is stable, this so formed O minus ion, it is conjugate base. O minus ion, if it is stable, then it cannot take back this H plus. So availability of H plus in the solution or reaction medium increases. If availability of H plus increases or H plus ion concentration increases, acidic nature increases. So if O minus is stable, H plus ion concentration increases in solution. If H plus ion concentration increases, acidic nature increases. Acidic nature increases. All of are clear? So acidic nature depends upon the conjugate base formed after releasing the proton. The conjugate base formed after releasing the proton. Clear? ప్రోటాన్ను విడుదల చేసిన తర్వాత ఏర్పడిన సంయుగ్మ క్షారము స్థిరమైనది అయితే ద్రావణంలో H ప్లస్ అయాన్ గాఢత పెరుగుతుంది. H ప్లస్ అయాన్ గాఢత పెరిగినట్లయితే ఆమ్ల స్వభావము పెరుగుతుంది. రైట్? ఇప్పుడు O మైనస్ సంయుగ్మ క్షారం యొక్క స్థిరత్వం చూద్దాం. ఇక్కడ CH3OH ఈ కార్బన్ ఆక్సిజన్ మధ్య ఉన్న సిగ్మా బంధం ద్వారా ఈ కార్బన్ మిథైల్ గ్రూప్ ఎలక్ట్రాన్ సాంద్రతను పెంచుతుంది. దీన్నే మనము పాజిటివ్ ఇండక్టివ్ ఎఫెక్ట్ అని చెప్పుకున్నాం. సో మిథైల్ గ్రూప్ యొక్క పాజిటివ్ ఇండక్టివ్ ఎఫెక్ట్ వలన ఆక్సిజన్ పై ఎలక్ట్రాన్ సాంద్రత పెరుగుతుంది. ఇక్కడ చూద్దాం. ఇథైల్లో 2 కార్బన్లు ఉన్నాయి. ఇక్కడ ఒక కార్బన్ ఉంది, ఇక్కడ ఒక CH3 గ్రూప్ ఉంది, ఇక్కడ CH2 గ్రూప్ ఉంది. రైట్? సో 2 కార్బన్లు కూడా ఎలక్ట్రాన్ విడుదల చేసే గ్రూపులే. కాబట్టి ఇక్కడ ఎలక్ట్రాన్ విడుదల చేసే స్వభావము ఇథైల్ గ్రూపుకు మిథైల్ కంటే ఎక్కువ ఉంటుంది. కాబట్టి ఏమవుతుంది? ఫలితంగా ఆక్సిజన్ పై ఎలక్ట్రాన్ సాంద్రత పెరుగుతుంది. ఇక్కడ చూద్దాం. ఇక్కడ 2 మిథైల్ గ్రూపులు, ఈ 2 మిథైల్ గ్రూపులు కూడా ఎలక్ట్రాన్ను విడుదల చేసే స్వభావాన్ని కలిగి ఉన్నవి. కాబట్టి ఈ 2 మిథైల్ గ్రూపులు ఎలక్ట్రాన్ సాంద్రతను ఈ కార్బన్ పైన పెంచుతాయి, సెకండరీ కార్బన్ పైన. ఈ సెకండరీ కార్బన్ నుంచి ఎలక్ట్రాన్ సాంద్రత ఆక్సిజన్కు ట్రాన్స్ఫర్ అవుతుంది. సో ఇక్కడ ఎలక్ట్రాన్ సాంద్రత ఆక్సిజన్ పై ఈ మిథనాల్ ఈథనాల్ కంటే ఎక్కువ ఉంటుంది. ఇక్కడ కూడా ప్లస్ ఎఫెక్ట్. ఇందులో మూడు మిథైల్ గ్రూపులు ఉన్నాయి. సో ఈ మిథైల్ గ్రూప్ ఎలక్ట్రాన్ సాంద్రతను పెంచుతుంది. ఇట్ ఈస్ ఆల్సో ప్లస్ ఎఫెక్టివ్ గ్రూప్. ఇట్ ఈస్ ఆల్సో ప్లస్ ఎఫెక్టివ్ గ్రూప్. So this carbon, tertiary carbon, it increases electron density more over oxygen when compared to isopropanol, ethanol and methanol. So methanol, ethanol, isopropanol, butanol. మిథనాల్ నుంచి టెర్షరీ బ్యూటనాల్కు పోయినప్పుడు ఎలక్ట్రాన్ సాంద్రత ఆక్సిజన్ పై క్రమంగా పెరుగుతుంది. ఆక్సిజన్ పైన క్రమంగా పెరిగితే ఏమవుతుంది? ఆక్సిజన్ పైన ఆల్రెడీ రుణావేశం ఉందమ్మా. ఈ రుణావేశము అంటే ప్రోటాన్ కోల్పోయిన తర్వాత ఈ రుణావేశము మరియు ఇక్కడ మిథైల్ గ్రూపులు విడుదల చేసిన ఎలక్ట్రాన్ సాంద్రత మధ్య వికర్షణలు పెరుగుతాయి, రిపల్షన్స్ పెరుగుతాయి. రైట్? యాజ్ ప్లస్ ఐ ఎఫెక్ట్ ఇంక్రీజెస్, repulsions between negative charge, nothing but electrons on oxygen and electron density from alkyl groups increases. So if repulsions increases, stability of O minus decreases. Stability of O minus decreases. If stability of O minus decreases, acidic nature decreases. Acidic nature also decreases. Right? Now, what is the answer? I mean, which one is more acidic? Which one is more acidic? Methanol is more acidic, right? So methanol is more acidic than that of ethanol, is more acidic than that of isopropanol, is more acidic than that of tertiary butyl alcohol. This is in solution state or aqueous state. In solution state or aqueous state. Now in vapor state. In vapor state. See, in vapor state, molecules are away from each other. So it is reverse to the solution state. So tertiary butanol is more acidic than that of isopropanol, is more acidic than that of ethanol, is more acidic than that of methanol. Right? Remember this explanation for solution in solution state. Right? There is no proper explanation for vapor state. Clear? Right. Now, see, let us take reactivity. What could be the order of reactivity of different alcohols based on acidic nature? Based on acidic nature. For example, let us take ethanol, right? Next, isopropanol. Next, tertiary butanol. Now, which compound is more reactive with respect to acidic character? See, if acidic character increases, they can react with the bases or base-like substances easily, right? They can react with bases or base-like substances easily. So, ethanol is more reactive than that of isopropanol is more reactive than that of tertiary butanol, right? So, acidic character is decreasing, therefore reactivity is decreasing. Now, let us see some reactions. Before going to discuss about reactions, let us discuss what kind of reactions are possible in alcohols, right? See, if we take alcohol, in alcohols, there will be carbon, there will be oxygen, there will be hydrogen. So, with respect to hydrogen, hydrogen is acidic in nature, so that acid base reactions are possible. Hydrogen is acidic in nature, so that acid base reactions are possible. Right? This is one possible reaction. And another one is over oxygen, there are two lone pairs, right? Over oxygen, there are two lone pairs. So, with respect to lone pairs, alcohols can act as nucleophiles. Act as nucleophiles, right? Now, see, alkyl groups are electron donating groups. Alkyl groups are electron donating groups, right? So, due to plus I nature, act as electrophiles, right? For example, OH, it is protonated, right? This lone pair is donated to the hydrogen or H plus from the acid. Then OH group, it converts into, let us say there is carbon. OH group, it converts into OH2 plus. Now, OH group is poor leaving group, right? OH group is poor leaving group. Poor leaving group. Whereas OH2 plus is good leaving group. Good leaving group because of positive charge over oxygen. So, this carbon, it gets partial positive charge. Alcoholic carbon, it gets partial positive charge. The magnitude of partial positive charge will be more because of good leaving nature of OH2 plus. When there is more positive charge, it can accept the electron density easily, right? So here, alcohols with respect to carbon, they act as electrophiles, right? Due to plus I effect, electron density will be more over the carbon, right? So this electron density can be donated to the partially positively charged carbon so that they act as electrophiles, right? So carbon, it acts as electrophile. Oxygen, due to lone pair, act as nucleophile. Hydrogen, due to more electronegativity of oxygen and hydrogen, hydrogen can be released as acidic hydrogen, right? So that acidic hydrogen reacts with the bases nothing but acid base reactions, right? So this hydrogen is acidic in nature. Why it is acidic? Due to more polarity of oxygen hydrogen bond, or hydrogen is bonded to more electronegative oxygen. Therefore, hydrogen is acidic. When it is acidic, acid base reaction takes place. So we can observe three types of reactions. One is acid base reaction, another one is nucleophilic reactions, another one is electrophilic reactions. Right? Now let us see the reactions. See, first one is reaction with metals. For example, ROH, alcohol, when it is allowed to react with sodium metal. Sodium metal is acidic in nature. So it releases one electron, converts into Na plus. That Na plus reacts with O minus because hydrogen it comes out as H plus. It is acidic. So H plus takes the electron released from the sodium and converts into hydrogen gas. Right? So the products are RONA. RO minus Na plus. And hydrogen gas will be released. Right? See, this is half mole hydrogen gas. Now, the same alcohol, if it is allowed to react with aluminium. See, aluminium is a trivalent. Aluminium can release 3 electrons and converts into tripositive ion, Al plus 3. Right. So, alcohols, RO minus, alkoxide ion. So, 3 moles of alkoxide ions, 3 moles of alkoxide ions, they bond with Al plus 3. It results aluminium alkoxide, and hydrogen gas, right? For example, in the place of alkyl group, if we take methyl, if R is CH3, what is the product? CH3O taken thrice aluminium. So aluminium methoxide. If R is isopropyl, right? Here, one second. R is CH3. CH3, CH3. This is isopropyl. Then it gives CH3, CH3O taken thrice aluminium. This is aluminium isopropoxide. Aluminium isopropoxide. This is reaction with the metals. So metals reacts with alcohols and releases hydrogen. Right? Now, see, this reaction can be used to distinguish esters from alcohols. Esters from alcohols, because when hydrogen gas is liberated, we can observe the effervescence, right? దీన్నే తెలుగులో బుసబుసమని పొంగే వాయువు విడుదలవుతుంది. సో లోహాలతో చర్యనొందుట వలన ఆల్కహాల్లకు ఆమ్ల స్వభావము కలిగి ఉంటుంది. నెక్స్ట్ ఇంకొక చర్య తీసుకుందాం, అల్కైలేషన్. అల్కైలేషన్, ఈ అల్కైలేషన్లో సోడియం ఆల్కాక్సైడ్, ఇంతకుముందు చెప్పుకున్నాం. సోడియం ఆల్కాక్సైడ్ ఏ విధంగా ఏర్పడింది? ఆల్కహాల్ను సోడియం మెటల్తో చర్యనందిస్తే సోడియం ఆల్కాక్సైడ్ ఏర్పడింది, రైట్? ఈ సోడియం ఆల్కాక్సైడ్ను అల్కైల్ హ్యాలైడ్తో, ఈ అల్కైల్ హ్యాలైడ్ ప్రైమరీ అనుకుందాం. ఇప్పుడు ఏం చర్య జరుగుతుందో చెప్పండి. దీని కాన్సెప్ట్ మనం ఆల్రెడీ అల్కైల్ హ్యాలైడ్లు చెప్పుకునేటప్పుడు చెప్పుకున్నాము. ఏం చర్య జరుగుతుంది అంటే ఏ రకమైన చర్య జరుగుతుంది ఇక్కడ? న్యూక్లియోఫిలికా, ఎలక్ట్రోఫిలికా, స్వేచ్ఛా ప్రాతిపదికన? ఇక్కడ చూడండి, ఆక్సిజన్, ఆక్సిజన్ పైన ఒంటరి ఎలక్ట్రాన్ జంటలు ఉండుట వలన న్యూక్లియోఫైల్గా వ్యవహరిస్తుంది. ఇక్కడ ఆక్సిజన్ రుణావేశంను కలిగి ఉంది కాబట్టి దేనిగా వ్యవహరిస్తుంది? న్యూక్లియోఫైల్గా వ్యవహరిస్తుంది. ఈ న్యూక్లియోఫైల్ ఎక్కడ అటాక్ అవుతుంది? అల్కైల్ గ్రూప్ బ్యాక్ సైడ్ నుండి అటాక్ అవుతుంది, రైట్? ఎందుకు ఫ్రంట్ సైడ్ నుండి అటాక్ కాదు? బికాస్ హాలోజన్ పైన 3 ఒంటరి ఎలక్ట్రాన్ జంటలు ఉంటాయి. ఈ రుణావేశాల వలన ఆక్సిజన్ పై ఉన్న రుణావేశము రెండు ఒకదానికొకటి వికర్షించుకుంటాయి కాబట్టి ఫ్రంట్ సైడ్ నుంచి అటాక్ కాకుండా బ్యాక్ సైడ్ నుంచి అటాక్ అవుతుంది. బ్యాక్ సైడ్ నుంచి అటాక్ కావడం అనేది ఏ చర్యా విధానం కీ పాయింట్? SN2, రైట్? లేదా ప్రైమరీ అనేది కూడా SN2. సో ఇప్పుడు O మైనస్ ఇక్కడ అటాక్ అయితే X మైనస్ బయటకు వెళ్తుందమ్మా. ఏమొస్తుంది? ROR, ఈథర్. దీన్నే ఈథర్ తయారీలో చెప్పుకుంటాం. బై ప్రోడక్ట్ ఏంటి? ఈ X మైనస్ Na ప్లస్ కలిసి సోడియం హ్యాలైడ్గా బయటకు పోతాయి, రైట్? దీని R డాష్ అనుకుందాం డిఫరెన్షియేషన్ కొరకు. ఇది ఒక మెథడ్ అల్కైలేషన్లో. రెండవ పద్ధతి, అల్కైలేషన్లోనే రెండవ పద్ధతి ఏంటంటే ఆల్కహాల్ను, ఇక్కడ దీనికి డిఫరెన్స్ ఏముంది? ఫస్ట్ దానికి సెకండ్ దానికి, ఫస్ట్ దాంట్లో ఈ ఆల్కహాల్ అనేది ఆవేశం లేదు ఆక్సిజన్ పైన, రైట్? ఇక్కడ RO మైనస్ ఉంది. ఈ RO మైనస్ అండ్ RO వితౌట్ చార్జ్ ఏది మంచి న్యూక్లియోఫైల్? రుణావేశమును కలిగి ఉన్న ది మంచి న్యూక్లియోఫైల్, బలమైన న్యూక్లియోఫైల్. ఏ న్యూక్లియోఫైల్ విత్ నెగటివ్ చార్జ్ ఈజ్ స్ట్రాంగర్ దాన్ దట్ ఆఫ్ వితౌట్ చార్జ్ with the same donor atom. So RO minus is better nucleophile or strong nucleophile than that of ROH, right? ROH. సో ఇక్కడ ఏం చేసాము? పూర్ న్యూక్లియోఫైల్ని కాస్త స్ట్రాంగ్ న్యూక్లియోఫైల్గా కన్వర్ట్ చేసి రియాక్షన్ తీసుకున్నాం. కానీ ఇక్కడ నేను పూర్ న్యూక్లియోఫైల్ కానే రియాక్షన్ జరపాలని అనుకుంటున్నాను. దానికి ఈ పూర్ న్యూక్లియోఫైల్తో కూడా రియాక్షన్ ఎఫెక్టివ్గా జరగాలి అంటే లీవింగ్ గ్రూప్ ఏ హాలోజన్ ఉండాలని చెప్పుకున్నాము? అయోడిన్, రైట్? సో ఇక్కడ మిథైల్ అయోడైడ్ తీసుకున్నాను. సో I మైనస్ ఈజ్ ఏ గుడ్ లీవింగ్ గ్రూప్ యాజ్ వెల్ యాజ్ గుడ్ న్యూక్లియోఫైల్, రైట్? సో వాట్ ఎవర్ ద RO minus available in the alcohol, that is sufficient for nucleophilic substitution reaction. So what is the product? ROMe, right? So Why this reaction is possible? Because available RO minus is sufficient or enough. Because I minus is good leaving group, right? Now, let us take another reaction of alkylation, third one. Again, let us take alcohol. It is allowed to react with dimethyl sulfate. Me2SO4, right? Dimethyl sulfate in presence of OH minus. In presence of OH minus. Now, it is also nucleophilic substitution reaction. Nucleophilic substitution reaction. How? See here. First, alcohol, it is acidic. OH minus is base. Acid base reacts with each other to form alkoxide ion and water. Right? This alkoxide ion is a good nucleophile. It is a good nucleophile. So, poor nucleophile is converting into good nucleophile with a base. After converting it into good nucleophile or strong nucleophile, it reacts with dimethyl sulfate. See, in the sulfuric acid is H2SO4. This is sulfuric acid. In the sulfuric acid, in the place of hydrogens, there are methyl groups. So it is dimethyl sulfate. Now RO minus, it attacks from the back side. It is SN2 reaction. Now this electron density goes to the O minus. O minus. SO4 minus 2 comes out. The product is ROME, ether. Right? ROME is ether. So in all alkylation reactions, products are ethers. Clear? Now, let us take one more alkylation. Okay, directly we can take here in the place of R, methyl ethyl or propyl. Then treating with the Me2SO4, it gives ROME, right? So first reaction is reaction with the metals. In reaction with the metals, oxygen hydrogen bond cleavage can be observed, right? In alkylation reactions also, oxygen hydrogen bond cleavage can be observed. Oxygen hydrogen bond cleavage occurs. So reaction with metals, reaction with alkyl groups or alkylation. Which bond cleaves? Oxygen hydrogen bond of alcohols cleaves, right? Now let us take one more example, that is acylation. It is important. Acylation. See here. Alcohols react with carboxylic acids in presence of acid, like concentrated H2SO4, right? To form, see here, carboxylic acid and alcohol both are acidic in nature, but carboxy acids are more acidic, alcohols are less acidic. So one act as acid, another one act as base. So when acid base reaction takes place, H2O comes out. Dehydration takes place. Right? If we remove the water, OH and H, then what will get? R dash C double bond O. This is from carboxylic acid. OR. Right? This is from alcohol. This is ester. This is ester plus water. Right? Now this reaction invented by a scientist called Fisher. Fisher. So it is called Fisher esterification. Fisher esterification. Right? Now let us see the mechanism for this reaction. See, R C double bond O OH. See here, concentrated H2SO4, it releases acid. So H plus. It reacts with double bonded oxygen lone pair. This gives R dash C double bond O H. Oxygen is losing its electron density, it gets positive charge OH. Right? Now, at this stage, alcohol ROH. See, ROH, it acts as a nucleophile due to lone pair on oxygen. Right? So now, this nucleophile attacks on this electrophilic carbon because carbon gets partial positive charge. When new bond forms between carbon and oxygen, pi bond shifts to the positively charged oxygen. Pi bond shifts to the positively charged oxygen. Right? So, when pi bond transfers to the positively charged oxygen, positive charge nullifies, converts into the neutral. C. R dash C OH ROH here plus. Oxygen is losing electron density. Here OH. Now this is tetrahedral. So this nucleophilic substitution, sorry, this is nucleophile, right? This nucleophilic addition is occurring formation or that results in the formation of tetrahedral mechanism. So this mechanism, it follows tetrahedral mechanism. Tetrahedral mechanism. TD is tetrahedral. right? Now this tetrahedral here. See this electron density, it goes back to the oxygen. Hydrogen comes out as H plus. So whatever the H plus consumed in the first step, it is from acid. Again, the same H plus is releasing in this step. So H2SO4 is catalyst, right? Now this H plus, again it reacts with this OH group, one of these two OH groups. There is no such condition this H plus has to react with this OH only or this OH only. It can react with one of these two OH groups. Now it gives R dash COH OH2 plus OR, right? Now here, see, one of these two lone pairs will be transferred to the carbon, then double bond formation takes place. H2O goes out, right? R dash C double bond OH OR. Now oxygen is losing electron density, gets positive charge. Now this hydrogen comes out as H plus. R dash C double bond O OR. So finally this is ester. This is the mechanism. Clear? So in the examination, in the place of R, there may be any alkyl group like methyl, ethyl, propyl. In the place of R dash, there may be hydrogen. If it is hydrogen, formic acid, right? If it is hydrogen, here R dash, if it is hydrogen, we'll get alkyl ester, alkyl formate. If it is methyl group or ethyl group or propyl group, right? In alcohols, R cannot be hydrogen. If it is hydrogen, it will become water. So in case of alcohols, R must be alkyl group like methyl, ethyl, propyl. In case of carboxylic acids, R dash, it may be hydrogen or any alkyl group like methyl, ethyl, propyl. Clear? So Fischer esterification, it follows tetrahedral mechanism. First addition is taking place followed by elimination. So this type of reactions, what is eliminating here? Water is eliminating. This type of reactions are called condensation reactions. Condensation reactions are reactions in which first addition takes place followed by elimination. Addition elimination reactions are condensation. So formation of ester is an example of condensation reaction, right? And mechanism, it follows tetrahedral mechanism because tetrahedral intermediate is formed. Clear? Right. Now, I'll give you one question. See, RCO OH and R dash OH. Now, if this oxygen is labeled with a star mark, then how many products are possible? How many products are possible? Right? Number of products. Similarly, if we take carboxylic acid, here oxygen is not labeled, right? Simply we are taking oxygen unlabeled, treated with Alcohol. In alcohol, oxygen is labeled. In the first case, carboxylic acid double bonded oxygen is labeled. In the second case, alcohol oxygen is labeled. Then how many products are possible? You can answer based on the mechanism. You can answer based on mechanism, right? So tomorrow, everybody should answer this question. Clear? Are you clear up to here? Any of you have any doubt? Thank you, one and all.
Thank you, sir.